Scientists and especially physicists are always looking for different quantities which they can measure so that they can find how they are related and see a pattern and manufacture a new physical quantity as and when needed. Then by using these relations, which they call laws of nature, they try to explain or predict an unknown scenario or future state given the present condition. If we take example of length as a physical quantity, a complete description of this quantity includes a unit and a magnitude. This unit is a standard reference for our measurement, and the magnitude gives how it compares to the standard. Thus, a length twice a meter is 2 meter and half of a meter is 0.5 meter. But you still might encounter problems where you will have to convert one unit to another for some physical quantities. To do that, we have to remember the conversion factor for different units and simply multiply it with the unit to be converted. Like length, nature is filled with many physical quantities. Some are as simple as mass or time, and some are complicated like energy. Scientists chose a set of these simple physical quantities and called them basic quantities. These are the most basic in nature and are completely independent of each other.
Why independent?
Take example of length and area. Area is just length squared. Hence we cannot consider both as a basic unit. You can see that all these quantities are associated with a completely different physical phenomena, like time or length, or heat or light. But nature sometimes interplays with these seemingly different quantities, and without proper understanding of these derived quantities, our knowledge of physics will be limited. When you multiply current by time, you get charge. As we learn more physics, we will come up with more such derived quantities. In fact, most of our journey in physics and other science will involve search of new meaningful derived physical quantities and their relationships.
You said meaningful relationships. What do you mean by that?
I can combine any two quantities, say luminous intensity and temperature. You can call this new quantity by any name, but does it represent any physical phenomena?
No, I don't think so.
Or probably we just don't know about it yet. So until we do, we say they are meaningless.
What happens to the unit of derived quantity when we multiply two or more physical quantity?
When we multiply two quantities, both the magnitude and units get multiplied. In the process, certain units might get cancelled if they are in both numerator and denominator.
So I can multiply two or more physical quantities, but can I add them too?
No, you can only add physical quantities with same units. Imagine, can you add length and mass or even meters to yard?
No, that sounds absurd. What will even be the unit of the new quantity we get?
Exactly. And that reminds me about error. That is errors in measurement.
You mean human error, right? Why is it important in science?
No, by error I mean both error caused by human and measuring device. Nothing in this world of nature is perfect, like the laws we put up in our textbooks. Having an idea about how much is the possibility of error in measurement is a good idea that decides with how much confidence we can believe in it.